Okay guys, so I'm sorry my other video like weirdly shorted out on me, so we're kind of getting started here even though I already have a picture drawn, but we're getting ourselves ready for our midterm, and so we're going to review a couple really key components that are definitely going to be really big on your midterm. So there's going to be some problems that I'm going to do with you, and then right afterwards there's going to be a problem that you do on your own, and that's going to be the part that I am looking for when I grade this video. So let's get started. Our first part is partitioning. Partitioning means to break up a line segment into some smaller pieces. And then when you see the word collinear, that means they are on the same line. So for this first problem here, as you can see, I kind of already got it started. I've got 3 points that are collinear on AC. It gives me a ratio of the partition, gives me some coordinates, and then it asks me to find the coordinate of point B. So I drew myself a picture here. AC means you start at A, you end at C. Point A has my points that are listed here. Point C has 3, 8, and I don't know what my B value is, so I'm going to put an X and a Y there. Now the ratio that is given to me is 2 to 1. It is AB, which is this piece right here, is a 2, and BC, this piece over here, is a 1. So this is a part to part ratio, one piece and one piece. So now I'm going to do my little kind of like saying that I have, the middle minus the first over the last minus the middle. I'm going to set that equal to my ratio. So my X values I'm going to do first. My middle X is X minus my first X is -9 over last minus middle. So my last X is a 3. Minus my middle X is an X. And I set that equal to my ratio, which is 2 to 1. Now I'm going to cross multiply. Before I do that though, I've got X minus a -9. When there's two negatives next to each other, I can make it a positive. And now we're going to cross multiply. Well, if I multiply any number by 1, it's just itself. So this is just X plus 9. Equals, and I'm going to cross multiply over here. So I've got 2 times 3 minus X. And so what I need to do here to solve this problem is I need to make sure I do a little bit of distributive property. So I do 2 times 3, which gives me 6. 2 times -X gives me -2X. And now I'm going to get all my X's to one side. So I'm going to add 2 to both sides. I get 3X plus 9 equals 6. I'm going to subtract that 9 from both sides. I get 3x equals -3. And then I divide both sides by the number in front of the x, which is 3, and I get -1 for my x value. So now let's do our y value. Same thing, middle minus first, last minus middle. So y minus -7 over 8 minus y, and I set it equal to my ratio, which is 2 over 1. Again, I've got minus and negative here, so I can put those two together and I can make it a plus. Now I'm going to cross multiply. So when I multiply these two across, I get y plus 7. And then again, I'm going to multiply these two across, so I get 2 times 8 minus y. And now again, I'm going to do some of the distributive property here. So 2 times 8 is 16. 2 times -y is -2y. I'm going to get all my y's to one side, so I'm going to add 2y to both sides. I get 3y plus 7 equals 16. I'm then going to take away 7 from both sides, so I get 3y equals 9. And then I'm going to divide both of them by 3. So I get y equals 3. So my final answer, the coordinates for point B, are -1 and +3 is my final answer. So now you've got another problem right below there where it says you do. So I'm going to move this up for you here so you can see a little bit easier. So now you can pause your video right here. You've got 3 points and your ratio, and you're going to find the coordinates of point B. So take a moment and try that problem. Okay, now we are on our second problem here. Again, it's partitioning. Points MT and D are collinear on MD. M is located here, T here, and D here. Now this time it's asking me for the value of the ratio. So I'm still gonna draw myself a picture because that is always, always helpful. Okay, let's zoom out. 3. All right, so I start at M and I end at D. T is somewhere in the center here. And I'm just going to rewrite my points. I'm just copying them now. Okay, so it asks me to find the ratio. So I'm still gonna do the same thing I did in the last problem, except this time it's gonna be a little bit easier. So I'm gonna pick my X values, and you can actually pick your X or your Y values. It's whatever makes your heart happy. So I'm gonna do middle minus first, last minus middle. Middle minus first, last minus middle, and this is the X's is what I'm doing. Now I don't have to set that equal to a ratio because that's what I'm trying to find. So now I'm just going to do a little bit of math here. Minus a negative really becomes a positive. 2 plus 4 equals 6. 6 minus 2 equals 4. My ratio is 6 to 4. Now I'm going to reduce it just a little bit. I can divide both of those by 2. So I can do 3 to 2 is my ratio of part to part. So this first part, MT, is a 3. This second part, TD, is a 2. Now, the question, though, asks me for the ratio of MT to MD. Now, that is different than the ratio I just found. The ratio I just found was MT to TD. So MT is 3, TD is 2. I want to know, though, MT to MD. So this was a part to part. This one is MT, that is a part, and MD is the whole thing. So it's a part to whole ratio. So if I look at my picture, MT is still a 3, but my MD ratio is this whole thing. So if I'm looking at the whole thing, I have 3 parts plus 2 parts. That is 5 parts total. So the answer that I'm looking for there is 3 to 5. Now, you've got yourself a problem right here. So again, take a moment. You can pause the video here and try out that second problem. Okay, so hopefully you are finished with that one. And now we're gonna work on our last partition problem together. So I move this just a little. Okay, again. Suppose R is plotted on the coordinate plane and is collinear with A and B. Now that I see collinear, I already know I'm going to draw myself a picture. Okay. A, B. So that means I start at A, I end at B. R is somewhere in the middle. Okay. Now I'm going to ignore the ratio for now. I'm just going to come and label my parts. A is -3, 4. And B is 2, -3. So now I'm going to try to find the coordinates of R, so I'm going to put X and Y there. Okay, so now I'm going to look at the ratio that's given to me. The ratio that's given to me is 1 to 3. Now the 1 goes along with the AR. So here's AR. I know this is a 1. The 3 goes along with AB. Now AB is the whole thing. So if the whole thing is 3, and I already used up 1 part, this second piece over here must be a 2, because when I add them together, I get to 3. And so now it's just a normal partition problem, except when I do the partitioning, I'm going to make sure that I use my ratio of 1 to 2. So it's middle minus first, last minus middle. Let's do our X's. Middle minus first, last minus middle. Set it equal to my ratio. Okay, now I'm going to, 2 minuses become a positive. Let's do some multiplication. I'm going to multiply these two together. 1 times this whole thing leaves it alone, so I get 2 minus X. and then I multiply down over here, 2 times x plus 3. Just like before, I need to distribute. So 2 times x is 2x, 2 times 3 is 6. I'm going to move this negative x over to this side by adding it. So if I add it to the other side, I get a 3x. Then I'm going to move my 6 over from the right to the left, and I'm going to subtract it. Then my final step is to get the x all by itself, so I'm going to divide both sides by a 3, and I get x equals negative 4 thirds. Now I'm going to do the same thing for my y's. Middle minus first over last minus middle. Set it equal to my ratio, cross multiply. 1 times this is going to leave it alone. I don't really need those parentheses, but that's okay. And then, right, because if I have the 1 there, nothing happens. 2 times y minus 4, I'm going to have to distribute like I just did. So 2 times y is 2y. 2 times negative 4, negative 8. I'm going to move this negative y over to this side by adding the y. And I'm going to move this negative 8 over by adding it. So you get 5 equals 3y. My last step is divide both sides by the 3. And you get y equals 5 thirds. So my final answer, the coordinates for point R are, where's my x value? Here it is. Negative 4 thirds and positive 5 thirds. And there is my final answer. Okay, so last partitioning problem that you're gonna do on your own. I'll move it up so we can see it a little better there. Okay, so take a moment and give that problem a try. Okay, friends, we are back now. We've got part B, which is writing equations of parallel and perpendicular lines, which again is going to be a huge part on your exam. So let's get started. Remember, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes, so you have to flip them and change the sign. So first problem we're going to do together. Are the two lines parallel, perpendicular, or neither? Well, in order to figure that out, I need to have these equations written in slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b, where the m is my slope and the b is my y-intercept. Now, I need to make sure both of these equations look like that one. That's the only way I can figure out if the slopes are the same or different. So in this first problem, that one is not written to look exactly like this. I want the y to be by itself, so I'm very quickly going to just move this 2 over to the other side by adding it. I do the opposite. So I get y equals 7x plus 2. And I can't combine those together because one has an x and one doesn't. So look, that now looks like that form. My slope for this one is a positive, whoa, that was unfortunate, but it's a positive 7. I apologize. Okay, now I'm going to do the same for line B. I want this one to look like this one. So the first thing I'm going to do is move my x to the other side. I'm going to subtract it. So I get 7y equals, now I want my x to be first, so I've got negative x and a positive 8. Now I still need to get the y by itself, so I'm going to divide by 7, and whatever I do on one side, I need to make sure I do to everything on the other side. So my equation now is y equals negative, and if there's nothing in front of the x, you can put a 1 there, negative 1/7 x plus 8 over 7, which is a weird, funky number, but I don't really care about that because all I care about is the slope. And what is the slope? I'm going to be smarter now with this highlighter. What is the slope? Oh man, it still did it. Dang nabbit. Unfortunate. Okay. What is the slope? This one's a 7. This one's a negative 1/7. Are they the same? No. Are they opposite reciprocals? So if I flipped this and changed the sign, would this be a positive 7? Yes. If I flipped 7 over 1, that becomes, or excuse me, 1 over 7, that becomes 7 over 1. And then I make a negative a positive, that would be this. So this first answer is perpendicular. These are perpendicular lines. Okay, oh, it went off a little bit there. Okay, these are perpendicular lines. Now, it is your turn to determine, are these two equations parallel, perpendicular, or neither? So for example 2, we are going to determine, we're actually going to write an equation of a parallel and a perpendicular line, still using the same ideas that I used for my last problem here. So the equation for line G is given by this equation right here. Suppose G is parallel to R and E is perpendicular to G. Point -10, 8 lies on both R and E. Write the equation in slope-intercept form for line R. So if I look back at line R, it is parallel. So this equation is a parallel equation. If I look at E, it says line E is perpendicular. So this is a perpendicular equation. That's an important thing to notice. Okay. So I'm going to write my equation in slope-intercept form. First thing I want to do is look at the equation that's given to me. And I look at it and I go, you know what? That is not written in slope-intercept form like we did before. So just like before, I actually have to change it and put it into slope-intercept form. So let's do that. The only thing I have to do is get this y by itself, so I'm going to divide everything by 5. So my equation for line G is y equals -2/5 x, and then 20 divided by 5 is -4. So this is like my general one. This is line G, my general, oh, you guys can't see that, my bad. That's my general line G, and that's what I'm going to use to help me with both of these parts. So write the equation that's parallel to this one that goes through these points. This point's my x, this point's my y. Very simply, what I'm going to do is I'm going to plug all of that information into slope-intercept form, and I'm going to solve for my b value, my unknown. So if I use this equation here, for the y, I'm going to plug in an 8 equals, now it's a parallel line, so the slope should be the same. So I'm going to take this exact same slope, -2/5, and I'm going to just copy it. My x is a -10, and I don't know what my b is. That's what I'm going to figure out. Now, don't let this fraction scare you. You can put it over a 1 and multiply straight across. So -2 times -10 is a +20. 5 times 1 is 5. Well, this is a fraction. 20 divided by 5 is just 4. And then to get the b by itself, I just subtract 4. My b value is 4. So now my final step is I'm going to take this piece of information and my slope, and I'm going to plug it back into the equation one more time to write my final answer. So my final answer is y equals -2/5 x plus 4. And that's the equation of a line that is parallel. Now I'm going to do the same thing, but I'm going to write the equation of a line that is perpendicular. So if it's perpendicular, I have to take this slope and I have to switch the sign, and they have to trade places. I'm still going to plug in an x and a y though. So y equals mx plus b. For my y, I'm plugging in an 8 again, equals, now my m, I have to flip these. 5/2 times my x value, -10. And I'm trying to figure out what my b is. Again, I'm going to make this into a fraction, multiply straight across. 5 times -10 is -50. Divided by 2. And if I divide -50 by 2, I get -25. Now to get my b by myself, I just add 25 on both sides. Sorry, I'm running out of space. And I get, so 25 plus 8, 33 is my B value. Sorry, I had a momentary brain lapse there. Couldn't do addition. So my final equation is y equals, go back to my slope, 5/2 x plus my B value is 33. Okay, fabulous. So now this problem in orange here, you are going to try this next, and I should zoom out so you can see it. This next problem. So take a moment and try that problem. Okay, gems, we have made it to our final section, triangle inequality theorems and the hinge theorem, which we just did, so you should feel like so great about all of this information. Okay, we together are going to find the length of all the side lengths that are in this triangle. Now, I have two angles that are marked as congruent. When I have two angles marked as congruent, that must mean this is an isosceles triangle. And when you have an isosceles triangle, the two angles are congruent and the side lengths that are directly across are also congruent. So this side and this side are the same. Well, that means if these two sides are exactly the same, they should be equal. So I'm going to take these two equations, I'm going to set them equal to each other to help me solve for x. So I'm going to do 2x minus 1 equals x plus 7. And then I'm just going to do a little bit of algebra here. So I'm going to move my x to the other side by subtracting it. I get x minus 1 equals 7. And then I'm going to add the 1 to both sides. I get x equals 8. Well, that's fine and dandy, but the question asked me to find the length of all of the sides of the triangle. So I'm going to take that 8, I'm going to plug it into every x that I see. So that means 2 times 8 minus 1, 8 plus 7, and 8 minus 4. So if I look at this side length over here, that's AB. 2 times 8 is 16. 16 minus 1 is 15. That means this side over here should be exactly the same, but I'm going to check it just to be sure. 7 plus 8 is 15, so I did that right. And then my last side at the bottom, AC, is 8 minus 4, which is 4. And now I'm done. That was so easy, right? So now you are going to try this next picture here, and you're going to be really careful when you read it because this time it's asking you to find the measure of the angles. So you're going to be really careful when you read this problem. So go ahead and give it a try. All right, our next problem together, we're going to write an inequality, finding the possible side lengths of the third side of a triangle if two side lengths are 24 and 32. So this is really easy. Here's all I have to do. I'm going to take these two numbers and I'm going to subtract them. So I'm going to do 32 minus 24. And I want to make sure I do bigger minus smaller because I can't have a negative side length for a triangle. That doesn't really make any sense. So when I subtract these two numbers, I get 8. That means the smallest number my triangle can be for the third side length is an 8. To find the biggest, I'm going to take these two numbers, I'm going to add them together. So 32 plus 24. And when I add those two together, I get 56. So the smallest it can be is 8, the biggest it can be is up to 56. So I'm going to write it now as an inequality. That means I have to have either a less than sign or a greater than sign. So I know the smallest it can be is 8, but my x value is going to be bigger than 8, but less than 56. And that's all I have to do. All right, so at 8 is less than x, which is less than 56 is my final answer. So now you go ahead and give this one a try. Okay, my gems, my loves, this is it, our final question. What is a range of possible values for x? So as I look in this picture here, I see two side lengths are already marked as congruent, as is the second one. As soon as you're given two side lengths with two separate triangles, I know I'm going to be using the hinge theorem. Okay. So hinge theorem is just telling me which side's going to be bigger, which side's going to be smaller, and I'm going to look at the side lengths to tell me which angle will be bigger. So if I go to this angle right here, 75 degrees, and I go straight across from it, the side length over there is 23. If I go from this angle here in blue, x minus 13, and go straight across, I've got 22. Now, I know this number 22 is smaller than this number 23. So that means this angle here in blue is smaller than this angle over here in pink. And I'm going to write that as an inequality. I'm going to say angle x minus 13 is less than angle 75. And what you want to make sure you do is you always keep the things together that are the same. So this has a degree sign, so when you're making your inequality, also use the other number that has a degree sign. Don't use these numbers over here. Don't get tricked. So all I'm going to do here is like a normal algebra problem. I'm going to solve for x. So what I'm going to do is I'm just going to add 13 to both sides. And I get x, excuse me, is less than 88. So I know that my x value cannot be bigger than 88. But that's just 1/2 of the inequality. That's the biggest number that it could be. I need to figure out, okay, what's the smallest number it can be? Now, every time I have a problem like this, I want to make sure that my angles are not negatives. And that's because it doesn't even make sense to have a negative angle. How are you going to measure that? That doesn't make any sense at all. So I can't have negative numbers. So the second equation I'm always going to do is I'm going to say, okay, this equation here must be bigger than 0, greater than 0. And I always want it to be bigger again because I don't want negative angles. That doesn't make sense for my problem. So again, I'm just going to solve this problem just like I did my last part. I'm just going to get the x by itself. So I'm going to add 13 to both sides. And I get that x has to be bigger than 13. So my x has to be bigger than 13, but smaller than 88. So I'm going to write that as one inequality. So 13 is less than x is less than 88. And that is my final answer. Okay. So now my beauties get so excited. Here is your final question of this video. So press pause, finish that off, and you are so golden for this midterm. I am proud of you for getting through this whole video. Fabulous job. I love you all. Good luck on your midterm.